Hi everyone, myself Arun, Assistant Professor R&D Engineering College. So I welcome you for this Tiva C series Launchpad Programming Workshop Lab 2. So in this tutorial, we are going to discuss about how the LEDs are interfaced with the GPIO pins of Tiva C series microcontroller. So already this 8-bit array LED connected to the GPIO pins of Texas microcontroller. So from this manual, we got the details of pin configuration and we have to use the same pins in our program. So this is the internal circuit diagram, how those LEDs are connected to the microcontroller pins. So this 8-bit array LEDs are connected to the microcontroller through the 3 to 8-bit decoder. So in this input pins of the decoder is serial data, serial clock and latch, and output is D0 to D7. In this output of D0 to D7, I am going to connect that LEDs. Then in this as serial data, serial clock, and latch input pins of the decoder connected to the PE2, PE3, PA5, that is GPIO pins of port E and port A. These pins are considered as a output pins. So in my program, the first portion is I'm going to enable the peripherals, that is GPIO pins. So after enable the peripheral pins, I'm going to the next section of the program is how to store the data. So what are the data I have to store by shifting this LEDs, data shifting. Then finally, I'm going to write the program how have to send the data, how we have to send the clock. So there are three portions in our program. So I'm going to tell you as usual, you have to start from the header file. You have to include the common header files here. From the first program, the one change is here you have to include driver library pinmap.h, driver library rom.h, because I'm going to use the latch here. So you have to include the line rom.h. And I have to start with my flow chart. The first line is peripheral clock. You have to enable the peripheral clock. Already you know how to develop the syntax for getting the system control clock set. Second, I'm going to enable the port E, port A. Next, port E, what are the pin I'm going to use? Pin 2, pin 3, and pin 4. Similarly, port A, I'm going to use pin 5. So first, enable the peripherals, set system control, peripheral enable, set the output, GPIO pin type, GPIO output. This already we discussed in the lab 1. So now I'm going to set the data in the output pins D0 to D7. So now you consider this is D0 to D7 array. This is the D0, this is D7. In this fashion, you have to connect 8 LEDs. So first LED I'm going to turn on, remaining LEDs is off. So I will consider the hexadecimal value. The first four zero bits consider 0. This value considers 1. So 0x01. Similarly, the second LED on, remaining LEDs here off, 0x02. Similarly, 0x04, 0x08, and 50 LEDs on, 10, 20, 40, 80. Likewise, you have to give the data and continuously I have to flashing the LED. Continuously, I am going to shift that position of the LED. So I have to put in that while loop. I hope you understand what is the explanation of this particular block of the program. Next, I'm going to move the value for PE2 and PE3. So why I have to move the value for PE2 and PE3? So as per the circuit diagram, PE2 means serial data. When you enable the PE2, that is PE2 equal to 1, the data will pass into the D0 to D7. When you have to enable the PE3, the clock will be sent into the clock will be carry the data, right? You know the procedure of shift register. The clock will carry the data. So I'm going to enable PE3 and PE2. For that, this is port E pin diagram. Port E has 5 pins: PE0, PE1, PE2, PE3, PE4, and PE5. So here PE2 is PE2. I set the 1, right? Means 40, 0x04. Similarly, PE3 is equal to 1, 0x 08, right? So that 4 bit you are consider, this bit is 1 4, this bit is 1 8. That's why here I'm going to move GPIO pin right, GPIO port E base pin to 0x04, pin 3 0x08. It means first I have to send the data 04. You have to check. What is the check? GPIO pin right, GPIO port E base, GPIO pin 4 comma 0. This comma 0 is nothing but data. What is the data for j equal to 0, j less than 7, j plus plus? Now we are going to check that GPIO pin right, GPIO port E base, GPIO pin 3 comma 0. So check j comma 0 equal to check. Check string and 1 less than j. You have to check up to the maximum value 0x80, starting from 0x01. So if 0x01 to 0x80 completed, then you have to erase all the data, have to send the clock. It means if check GPIO pin right, GPIO pin to 0x04, so data will be ready, and you have to enable the clock. So clock carry this 8-bit data, right? So now this 8-bit data, that is 0x01, 0x02, all the data are transferred to the LED array. So next, this is the program explanation. Next, I'm going to copy this program. Next, I'm going to copy this program and implement into the program into the board. So I have to copy this program. This is your Code Composer Studio. I have copied my program, that flashing of LED, and paste it here. After typing your program, you have to go to save your program and do that build. So build to check your errors. So there is no errors in the program, and go to click the debug. After the debug, you will get that memory map installation is complete. So program is completed. Next, I'm going to build your program into the microcontroller. Just click this run button. So now your program is ready for execution. It is downloaded in the microcontroller. Next, we will see the output in the microcontroller. So this is a flashing of LED output. I can zoom it here. So that 8 LEDs in this array. The LEDs are shifting. So what we programmed in this microcontroller. So you can reduce the delay and continue this experiment. You will get better clarity how the LEDs are shifting. And here we develop the program for LED only, but that LED stick is connected with the 7 segment display also. That is 7 segment display also is running. That's why we use that pin number PE4. Actually pin number PE2, PE3 used for flashing of LEDs, and pin 4 is used for stick that 7 segment display, right? Thank you.